So now we want to start talking about what determines a shoreline. So sometimes you've seen a shoreline that consists of cliffs, and other times you've seen a shoreline that's a nice sandy beach. So what is going to determine the type of shoreline that you have? Well, one is going to be the climate. So the climate is going to be basically what is the temperatures that are involved, and then also what's the amount of rainfall that you're going to get. Okay, another thing is going to be what is the strength and what is the direction of the waves. So if you have waves that have a lot of strength, they have a lot of amplitude, then that means that they're going to tend to cause a lot of erosion. It also depends on the direction of the waves. So if this is the shoreline, are the waves hitting the shoreline like this, or are the waves coming in at an angle? So that also can determine what kind of a shoreline that you end up with. Okay, what about the height of the tides? So the tides are going to raise the water level higher, so that can cause more erosion. What is the slope of the seafloor? As the seafloor approaches the land, what is the slope of that? So that can determine what kind of shoreline you have. Offshore features. So is there, out here, is there a coral reef? So that would be important because that would break up the waves before they could reach the shoreline. Hardness of the rocks. So some rocks are more resistant to the pounding of waves than others. Amount of sediment from the land. So you could have a river over here that it has a delta, and so that is where the material is being deposited out here in the ocean. And so the size of this delta is going to be determined by the amount of sediment that this river over here is carrying. Vegetation. So that vegetation has roots. The roots help to hold the sediment in place. And then tectonics. So do you have a place where the plates are colliding, or plates are being pulled apart, or plates are sliding past each other? So all of these things could influence the kind of coastline that you're going to end up with. So what kind of landforms do waves create? So you have coastal zones, and the coastal zone can be broken up into different parts. So you have the actual coast, and so it is going to be unaffected by the storm waves. So that is going to be where the water sloshes up onto the continent, but further inland than that is going to be the coast. It's going to be unaffected by the waves themselves. Okay, then you've got the back shore, which is going to be affected only by storm waves. So this part of the beach is only going to be affected when you have very severe storms that push a lot of water onto the land. Then you got the foreshore, which is between the high and the low tidal marks. So at high tide, the entire foreshore is underwater. At low tide, the foreshore is out of the water. Okay, then you got the near shore, which is going to be below the low tide, but still it's going to be affected by wave action, because we said that a wave is going to be churning the water in circles down to a certain depth, so that the near shore, it's always going to be underwater, but the bottom is going to be affected by wave action because of these circle things. And then the offshore it is so deep that even this thing is not touching the ocean floor, and so that's going to be the offshore. Okay, next thing, let's talk about shore circulation and refraction. So refraction is going to be the bending of a wave as it goes through a material. So a good example of this is if you've got a glass and then you fill it up with water and then you put a straw into it. Now the straw really is doing that. So the straw is straight. But when you look at the water, it looks as though this straw has been bent like this. Okay, and then that is going to be called refraction. It's the bending of, now in this case, it's the bending of light caused by the water. But a water wave, as it approaches the shoreline, begins to slow down. And so as it does so, if it's coming in at an angle, it will be refracted. And so here you have an example of water waves. So here is a shoreline, and you can see right here is a place where the shoreline sticks out into the ocean, and then over here it's not so much. Well, as the waves are approaching, so here's a wave that's approaching over here, it's getting shallower. So as the water is getting shallower, this wave is being bent in this direction. And then this wave over here, as it gets shallower, is being bent in this direction. So that means that this point right here is going to get pounded on more than this part right here. So what do we call it when rocks are being pounded upon? They're being eroded. So that these points are going to be eroded, but there's not going to be erosion occurring here. So what we call this deposition. So you're going to have deposition of sand in this region, and then you're going to have erosion caused by this. So what would be the net effect is that eventually the shoreline is going to look like this. That all of this material is going to be cut back and it's going to be filled in back here, so you'll just end up with a shoreline that's a straight line. Okay, now what this can do though is as these waves are approaching a shoreline, so here is your shoreline, here is the waves coming in this direction, it's going to push sand in this direction. But the water though, so once the water has pushed the sand this way, the water goes back into the ocean in this direction. And so that means that the sand is going to be stuck right here. Okay, then the next wave comes in and it can push the sand in this direction, and then when the water goes back out this way, it's going to leave the sand here. So what can happen is that the sand can migrate down the beach, and we're going to call that beach drifts. Okay, the overall direction that the sand is moving is as if there is a current of water in this direction. And so that's going to be called a longshore current. And then when the water is going back out to sea in this direction, that's what's known as a rip current or a rip tide when that happens. And they can be very, very dangerous, because if you happen to be swimming, then that current of water can take you out to sea like that. So safety tip, if you're out in the middle of if you're out on the beach and you get caught in a rip tide that's carrying you out to sea this way, don't try to fight it, swim sideways. So if you swim sideways like this, then you're going to get out of that rip current and you'll be okay. Otherwise, you just get swept out to sea because of it. So what are some different kinds of landforms that are going to be created as a result of this? So there are two kinds of shorelines, emergent and then submergent. So emergent is going to be where the land is sticking up out of the water, whereas submergent is going to be where the land or the water is basically sloshing up onto the coast. In an emergent coastline, erosion is what's going to be happening. So notice you have those big cliffs there. You're going to have sea stacks. So that originally, let's go back down to this picture here. As this thing gets hit, what can happen is the water can start to drill holes into this rock, and so you get sea caves when that happens. And so sometimes they can get connected, and then this material here can be eroded away, and so what you're left with is this thing is sticking up out of the water, isolated by itself. And so that's going to be called a sea stack when that happens. You're also going to have cliffs as a result of it. When you have submergent coastlines, then you're going to have deposition. And so you'll notice that you can have situations where you have a spit of land that is forming out to sea, and you can have lagoons, which are areas where there's water in it, but they're protected from the ocean by these spits of land that are in front of it. So here are some depositional landforms, and I will just let you read those words there. And then here are some erosional landforms. So notice the cliffs. Notice there's a lot of wave action. There's a lot of erosion going on. You have those sea stacks that are forming as a result of it. All right, let's take a break. When we come back, we will talk about what are some hazards associated with ocean currents and coastal processes.